Hello friends, today we are going to see examples of differentiation which involves chain rule. So we can consider this title as examples of differentiation part 3. You can check my earlier videos which involves part 1 and part 2. Now why we need chain rule or what is chain rule? See, basically chain rule is for the derivative of composite function. Now what is composite function? A function which involves 2 or 3 or more than one function. Let us say we know the derivative of sin x. Okay, the derivative of sin x is cos x. The derivative of x square is 2x. But what if someone asks us the derivative of sin 3x? I have mentioned it here. See, what is the derivative of sin 3x or maybe sin 9x, cos 4x? We know the derivative of x raised to 9, 9x raised to 8. But what about the derivative of x minus 2 raised to 9? 3x plus 5 raised to 10, log 2x plus 3. We know the derivative of log x. But how to find the derivative of log 2x plus 3? Again, e raised to x. The derivative of e raised to x is e raised to x. But what about the derivative of e raised to 9x, e raised to 3x? So, there are many functions which involves more than one function. They are known as composite functions. So, to find the derivative of such functions, we need chain rule. Now, what is chain rule? Let me explain you. Suppose we consider sin 3x is our y. So, let us say y is equal to sin 3x. So, what happens? We need to find dy by dx. How to find dy by dx? You cannot say directly the derivative of sin x is cos x. So, the derivative of sin 3x is cos 3x. No, it is not true. Okay, so the problem is 3x. The derivative of sin x is known, but the derivative of sin 3x, it is not easily calculated. So the problem is with 3x. If it was x, then it is directly cos x. So the problem is 3x. So consider 3x as u or any variable of your choice. I am choosing it as u. Okay, where u is equal to 3x. So what happens here is, we are assuming 3x as some new variable u, so it becomes sin u. Now what happens? We know the derivative of sin u. How can you find the derivative of sin u? As the derivative of sin x. The derivative of sin x is cos x. The derivative of sin u is cos u, if we are differentiating it with respect to u. So what happens here? Sin u will be there, cos u will be there, sometimes you will find log u is there. So here a new variable is introduced in place of x. Earlier it was y and x, the derivative of y with respect to x. Now we have involved 3x as u, so y is now function of u. U is function of x. So here it becomes a chain like this. Y involves u and this involves u. U involves x. So y, u and x. So it becomes just like a chain. Now to find the derivative of y with respect to x, we cannot find directly the derivative of y with respect to x because in between them there is a u. So the derivative of y with respect to u is possible. The derivative of u with respect to x is possible. So the derivative of y with respect to u is dy by du, and the derivative of u with respect to x is du by dx. Again the question comes, where is dy by dx? So the chain rule and its formula involves dy by dx is equal to, if you have introduced the variable u, then y derivative with respect to u is dy by du. Again u is there and it's dependent on x. So the derivative of u with respect to x is there, that is du by dx. And you can see here dy by du, du by dx, that will directly give you dy by dx. So this is the main formula for chain rule. If it involves one variable u between y and x. So now let us understand this with this example of sine 3x. Now y is our sine u, it is not sine 3x. So the derivative of y with respect to u, dy by du, in this case dy by du, sine u is there, so its derivative is cos u. On the other hand, u is equal to 3x, so u and x are there. The derivative of u with respect to x, that is du by dx. The derivative of 3x is, the derivative of x is 1 multiplied by 3. So the derivative of 3x is 3. So here we have dy by du as cos u, du by dx as 3, and by this formula dy by dx will be equal to dy by du. It is cos u into du by dx. Du by dx is 3, so multiply by 3. It is not cos u 3 or cos 3u. Cos u is 1 and 3 is different, so this is 3 into cos u. 3 cos u. Again replace u, whatever we have assumed here, u was our 3x. U is equal to 3x. So replacing the value of u, this will become 3 cos 3x. So the derivative of sin x is 3 cos 3x, not only cos 3x. Okay, so chain rule is for the derivative of some composite functions which involves more than one function. Sin x is not there, sin 3x, sin 9x. So similarly, sin 3x you can find the derivative of sin 9x also. Again, what happens if we have cos 4x? So you have to consider cos u, and u is just like this 4x here. And then the derivative of cos x is minus sin x. So cos u will be there, minus sin u will be there. The derivative of 4x will be 4, and you can solve it by this method. What is important here is y involves u. So the derivative of y with respect to u, dy by du. U involves x, so the derivative of u with respect to x is du by dx. If we multiply this both, then it will become dy by du into du by dx, and this is the chain rule to find dy by dx. See, finally we have y with respect to x only. The derivative with respect to x is only there. Only x and y, two variables are there. We are inviting u for our convenience. So we need to replace u also at the last. U was 3x. So the final answer will involve y and x only. Okay. Now what happens if we have more than two functions involved? Let us say we have y is equal to sine square 3x. Now what happens here? Some function square is there, sine is there, and 3x is there. So it involves three functions here. So we need to assume this sine square 3x as some function square. So let us say u square. Okay. Let us say u is equal to sine 3x. So some function square is u. Let us say u square. U is our sine 3x. Now what happens? Sine 3x is there. So we need to choose sine 3x in 3x something like v. So this will become u is equal to, let me write down it here only, sine v. Okay, and v is equal to 3x. So more than two functions, sine square and 3x. Square, sine and 3x. There are three functions. So first you have to assume whole square is there. So u square. U is our sine 3x. Sine 3x is there. So let us choose 3x as v. So it will become sine v. And our v is 3x. So here the chain rule involves y as a function of u, u as a function of v, and v as a function of x. So the derivative of y with respect to u, dy by du. The derivative of u with respect to v, du by dv. The derivative of v with respect to x, dv by dx. So in this case, the formula will be like this: dy by dx. Y is function of u, so dy by du. U is function of v, so du by dv. V is function of x, so dv by dx. Okay, clear? Y function of u function of v function of x. So dy by du, du by dv, dv by dx. So if we want to solve this, the derivative of y with respect to u, dy by du is 2u. The derivative of u involves sine v. So dy by dv, du by dv is, the derivative of sine v is cos v, and v, dv by dx, the derivative of v with respect to x, dv by dx is 3. So let me find all the values. Dy by du, 2u, it is u square, so 2u, du by dv, since it is sine v, the derivative of sine v is cos v, and v is equal to 3x, so dv by dx is 3. 2u, cos v and 3. The multiplication of all this will be put here. Dy by du, 2u into du by dv cos v, multiply by dv by dx was 3, so this multiply by 3, so 3 into 2, 6u cos v. Now replace u and v also. U is equal to sine 3x, okay, and v is equal to 3x. So 6, the value of u, sine 3x, into cos v, v is 3x, so into cos 3x. So the derivative of sine square 3x is 6 sine 3x into cos 3x. So friends, in this way you can find the derivative of u, derivative of v, and then substitute it here, just like dy by du, du by dx was there. Here it is dy by du, du by dv, and dv by dx. So when three functions are there, y is a function of u is a function of v, and at last v is function of x. So y, u, v, x, chain, again chain. Here also y, u and x. So it was also a chain. So that's why it is known as chain rule. Thank you friends.